Gemma 4 effectively generated a video.
And something that is very exciting here is that it's fully running on device. So this is running in an Android phone, completely offline in airplane mode without making any connection to any external server.
Hi everyone, welcome to the Agent Factory, the podcast that goes beyond the hype and dive into building production-ready AI agents. I'm Shir Meir Lodor.
And I'm Vlad Kolesnikov. I'm super excited to be back to the podcast. And today we're going to talk about a new major milestone in open models development. It's Gemma 4, a new model by Google DeepMind with great agentic capabilities right to this show. And to talk about this, we invited Omar Sanseviero from developer experience of Google DeepMind. Omar is behind the development of many open models that Google DeepMind released.
Yeah, thank you for having me here. Very excited.
Welcome to the Agent Factory, Omar. I heard that Gemma 4 is considered one of the most intelligent families of open models that can run on a single GPU. And I know both of you, Vlad and Omar, prepared for us some fun demos to show us those impressive capabilities, from on-device agent with skills to multimodal and code execution. But I wanted to ask you, Omar, before we dive into the demos, can you tell us what does Gemma 4 unlock for agent developers?
Yeah, of course. So Gemma 4 is the latest model that we have released. It brings very powerful capabilities across 4 different sizes, and they deliver very, very, very high intelligence per parameter. So let me show you a couple of examples here. So Gemma 4 has been built on the same research as Gemini 3, which means that you have very strong capabilities, especially for agentic things and coding. So in this first demo, you can see that you can vibe code. And something that is very exciting here is that it's fully running on device. So this is running in an Android phone, completely offline in airplane mode without making any connection to any external server. In the demo in the middle, what you can see is many instances of Gemma running locally. So each of these agents is building a different SVG. And at the end of the demo, it will show this gallery of SVGs created by the different models. This means that you can have many instances of Gemma running locally to do a certain task. And finally, in this third demo, you can see Gemma also running in an Android phone, being able to pick different skills, such as playing the piano, and using those skills to realize certain tasks. So all of this is very exciting. For developers building agentic experiences, this means that you can run very powerful things with very little hardware overhead. So some of the new things that Gemma 4 has, for example, function calling, structured JSON output, system instructions, and very high quality multimodal understanding. This allows the models to interact with different tools, with different APIs. And all of this can come in a single consumer GPU. So you can probably run this at home or even in the phone that you have in your pocket. All of this, by the way, is super exciting as well because all of the things that unlock for privacy and sovereign AI reasons.
That's pretty crazy. I feel like what we were able to do a couple of years ago or even 1 year ago with API models like Gemini, now we can do with self-hosted models like Gemma that you can even run on your device, on your Mac. Pretty incredible. So for developers who want to go ahead and start to implement using this model and build those agentic capabilities on device or on the cloud, what is the license of this model?
Yeah, so one of the things that is critical for the development of Gemma is that we're talking all the time with the community. We are talking with the startups, we're talking with developers, we're talking with all kinds of companies that want to build on top of AI. So we have brought all of that feedback to decide which are the different things that we'll do. And the license that we had was definitely one of the major feedback points. So for Gemma 4, we decided to go with an Apache 2 license, which means that you have lots of flexibility in how you can use this model.
Yeah, that's a major change, and it truly unlocks innovation on top of what Google has done. And we are very excited to see what people come up with. And honestly, just the first few hours after releasing the model, we already heard about great things that people made. with the model, especially given the license and just like permissiveness of building new innovation on top of it.
Yeah, the license
Yeah.
thing is pretty groundbreaking. Thank you, in the name of developers, for doing that. And I know, Vlad, you prepared for us some cool agent demos with Gemma 4. Do you want to show them?
Yeah, I had a chance to play with the model before, so I'm excited to show what I discovered. First demo I'd like to show is a food tour agent. It's an ADK agent that has Google Maps MCP server connected, and it is powered by Gemma 4. So now the agent sees that I want to find best places in Seattle that sell ramen, and I want to stay under $30. It recognizes that this dish is in fact ramen, and it needs to search for places that have highest ratings in Seattle, and it found a few. Now, obviously, since I asked for a tour, the agent needs to also make sure that routes between those places are walkable. So it takes that short list of places and finds routes that actually make sense as a food tour within my budget. And after thinking a little bit more, given that it needs to process quite a lot of information, it gets some details from those search results and makes its final decision on, on the specific places that we want to go to, and what are the tips for those specific places, what to buy and what to avoid. And that's all within the budget that I set at the beginning.
That is very cool. I liked it how it shows like the really best places and just focused on two, because ramen is a lot of food. So you cannot probably do more than two at once. And you also have a bit of a walk just between them, so you can build the appetite for the second place. So very nice.
Yeah, it's super fun. I think the fact that we can run these models, yeah, it's super exciting. Being able to run them locally, I can imagine myself being in a trip and wanting to know where to go. And something that is exciting is that you can try these models in the favorite tools, right? Like if you like to use ADK or whichever is your favorite tool, we collaborated with the open source ecosystem to ensure that you could try the model. So it's extremely exciting that we had ADK support on day 0, for example, and that developers that are already trying out ADK can build with Gemma very quickly without having to learn lots of new tools, which is quite nice.
Yep, certainly. I have another demo. So this demo that I'm going to show you uses a model, Gemma 4 31B instruction tuned, deployed in Cloud Run using NVIDIA RTX 6000 Pro GPUs. But that's not the most exciting part of the demo. The most exciting part is that all this agent has is ability to generate and execute Python code. Right? It has a tool that is based on Pyodide, basically a sandbox kind of oriented execution environment that effectively runs in Node.js. It's this kind of interpretation mechanism for lightweight sandboxes. Obviously, in production environments, you want to have proper sandboxes that are scalable, that are properly isolated, and in the description of this video, I will share with you one of the ways to deploy a secure sandbox in Cloud Run. But talking about this demo, I asked the model effectively to express itself through animation, and the model decided to use Matplotlib. And in general, I'm, as a technical person, I'm excited that the model decides to make an animation using math and physics. You can see how the model reasons about using different libraries and even writing a little physics engine and using LaTeX script, the formatting, which rightfully ADK Web doesn't necessarily visualize. It's fine. So it tries to run some Python code, then it fails. Oh, and it fails actually because of pyodide, because matplotlib uses acceleration and different CPU features, and turns out that WebAssembly backend that drives this pyodide through Node.js, it's not quite um, powerful enough. So it finds an alternative way to do the same thing. And now see, Gemma 4 effectively generated a video. I mean, it's not really the case, but it looks like a video because it's an animation. It has real world physics in it, and it is a bouncing ball that Gemma 4 coded just now in front of our eyes.
This is so cool, and I must say that what is really cool for me that it, as you said, actually adheres to the law of physics. Like it goes by the regular gravity rules. Um, yeah.
Yeah,
So
that's one of the biggest jumps we saw from Gemma 3 to Gemma 4. The world understanding capabilities of the model are much, much higher. So for things such as how the world works, things such as understanding gravity, all of those things paired with the reasoning capabilities. So being able to think about a complex problem such as this one and be able to generate and backtrack, and when it gets issues to be able to figure out what's the right path to get the answer. This shows super well how Gemma can tackle this kind of tasks, which is super exciting to see.
Yeah, so Gemma 4 effectively runs like a sort of an autonomous agent here. So if you think about it, I give it the task, it starts iterating, fails, like, okay, I'm going to try another way. And with the modern techniques that we have with agents, when they self-learning, they can save memories, they can do context compression, right? So which is important. But even without context compression, think about Gemma 4 and the 256K context. A year ago, 256K context, not even like the every commercial model had this size of the context. Yeah, with Gemini, we're kind of lucky, but let's think about the rest of the industry. And now you have 128 on your phone. It's kind of big deal.
yeah. It's pretty incredible, and I've been seeing those code execution agents everywhere these days. So why do you think is that, Vlad? Why are they gaining so much popularity?
I think there are multiple reasons, but the majors are first, models actually become quite smart and quite good in writing code. Obviously, it's part of the big research that all the major labs, including DeepMind, do. Um, they become better coders. And second, with this concept of just giving models and giving agents ultimately tools and skills, it unlocks these autonomous capabilities when, okay, I'm giving these tools, I can do these things, and I can like just go towards the goal that the user gave me. And I think that's the major reason why it's gonna it exploded, because with code, and we software engineers, we know this, can help you do many things, and that's what agents do too.
I think there are two different layers, right? Like one layer is the model capabilities, which are super strong nowadays compared to 2 years ago. And this other layer that Vlad mentioned that is super critical, which is the integration layer, right? So how do we provide access to the models, to all of these tools, these APIs? And over the last year, there have been many companies, many research labs, many institutions just providing tools to the community so people can interact with their services through an agentic system. And as both are evolving in parallel, it's super exciting to see where the community is getting at. Just thinking where we will be in 6 months, even 3 months from now. Yeah, I can't wait for it.
Yeah, super exciting.
Certainly.
I'm really excited to see how I know, like a year or two ago we kept on talking about the limitations of LLM and all the things they couldn't do, like math or physics or things like that. But now, with connecting them the ability to code and build their own scripts, it basically unlocks a whole world of new possibilities. for agents or for AI powered applications. So super exciting. Thank you for the great demonstration, Vlad. And one more question I had, like, let's think about the practical aspects for developer. How much does it cost to run this kind of software that you just showed us?
Oh, you mean the fact that I mentioned that it's running on Cloud Run?
Mm-hmm.
So if I run it just for myself, and it honestly an overkill with such a GPU, but it's still just a few dollars an hour. And the best thing, it actually scales to zero when I'm not using it. So if if I for some reason stop using agents, I don't waste money on GPU just that sits there and collects dust, presumably.
Yeah, I think that's one of the coolest things that people don't realize. When you use Gemini, or other API-based model, you pay for each API call based the number of tokens, right? And when you use an open model and host it yourself, all that you pay for is the hosting. And if you use something like Cloud Run, it just scales to zero when you don't use it. So that's a massive benefit. And now when open models are getting so powerful, there really is a time to start considering that kind of transition. Super, super cool. Thank you for showing us that, Vlad. Yeah, so now I think we have a few more questions as a part of our developer Q&A segment for you, Omar. And also here's a reminder for our audience, if you would like to ask question to us or to our guests, feel free to just add your question to social media with the hashtag The Agent Factory, or just ask your questions in the comment for this show.
Okay, so here's the first question. Omar, the model has so many new capabilities, especially kind of looking back at Gemma 3, it's truly a new generation. What are the architectural decisions that the team had to make to kind of create this relatively small but very mighty model, very powerful model for us and for the industry?
Yeah. Of course, some parts are more on the architecture, some parts are more on how we train the model itself. But let me share a couple. The first one would be that with Gemma 3, we only released dense models, and with Gemma 4, we are releasing our first MOE. That means mixture of experts. And this is an architecture that is optimized for extremely extremely good latency. So it's a very, very fast model. It can scale very well, and it's a great model architecture for deployment and production setups. The second architectural decision was per layer embeddings for the very small models. So the small models are called E2B and E4B. So although those models have more than 2 billion or 4 billion parameters, the architectural decision, these per layer embeddings, allows the models to run with only 2 billion or 4 billion activated parameters, or at least it means that these models run very cheaply in GPU. So you don't need a super heavy GPU to be able to execute with these models. One final decision that we took was to make the multimodal capabilities better. To explain that, with Gemma 3, we only accepted a couple of fixed resolutions. So the model was not very flexible in which was the resolution of the images that could go as input. With Gemma 4, we changed how the vision encoder accepts images to accept a variable aspect ratio. That means that you can pass images of different sizes, of different ratios, and the model can understand those images even if they go outside the ranges in which the model was trained. That's very interesting because depending on the task, you may want different aspect ratios. So some images for some tasks where you require lots of attention for the detail, you may want a very different aspect ratio. And when you look at other where it's only, I don't know, understanding what's in an image, you may want to use a different one. So these are just 3 examples. There is actually a great blog post that I recommend that does a full architecture deep dive of how Gemma 3 versus Gemma 4, and how the MOE versus the dense versus the super small Gemma 4 models were designed. And we will put that in the comments.
Let's not forget to add this to the show notes. Thank you, Omar, for saying that. I'm really curious. I'm sure that also others are. How is this model, this open model, is comparing to Gemini?
Yeah, I mean, they are very, very different, of course. So Gemma is designed to run on device. It's designed to be the best open model that can run in a single consumer GPU. Gemini is a much larger model. So of course, it can solve much more complex tasks. Uh, Especially you can see this in world understanding. So we spoke a bit about this already. So how much knowledge a model can have about different facts, about what's about information about the world, let's say geography, finance, science, and so on. Usually the larger models can capture much more information just because they have many more parameters. So I would say like the capabilities of the Gemini models are much stronger, and usually they have much better word knowledge and general knowledge of the world. Uh, but for certain types of tasks, such as some instruction following, simple agentic use cases, coding, and so on, the Gemma models can perform very, very well. So it really depends on your use case. One other thing where Gemma is quite exciting is to fine-tune the model. So you can fine-tune the model for your own use cases. Let's say that you have certain types of data, let's say from privacy setup, such as a hospital or a finance setup, and you need to train a model and deploy it within your own infrastructure or using some of the cloud services that have air-gapped solutions. With Gemma, you can fine-tune the model and deploy them there.
Yeah, I wanted to mention that this is one of the things I'm most excited about. I've started to work on a demo myself on fine-tuning Gemma 4 on using Cloud Run jobs, actually, with the new GPU that Vlad mentioned. So hopefully by the time we publish this show, I can also add this to the show note, and everyone can kind of walk through the code and do their own fine-tuning, because I think with open model, this is one of the major unlocks, that you can create a specialized expert for your data set and host it yourself and have the full control.
Well, that's a wrap. We hope now you have a better understanding of what Gemma 4 is and how to get started with it and what it actually unlocks for agent development.
And thank you so much, Omar, for joining the show today to talk to us about Gemma 4.
Yeah, thank you. This was super fun.
And for our audience, all the resources we discussed and would be shared in the show notes. And if you have a question or feedback for us, please add it to the comments for the show. And don't forget to subscribe to Google Cloud Tech to see more episodes of the Agent Factory.
Join us at our next episode where we'll be talking about another topic on production-ready agents. Until then, keep your code clean and your agents smart. I'm Vlad Kolesnikov.
I'm Shir Meir Lador.
I'm Omar Sanseviero.
Powering down.